find the inverse of the function g of x equals x squared minus 6x plus 9, x less than or equal to 3, and we want to sketch the graph of each. Okay. Now for this one, x squared minus 6x plus 9, it may be a little bit easier just to factor this. Okay, just going to be x minus 3 quantity squared, right? So this one is actually going to just be a parabola, right? It's our basic U shape, but this minus 3 tells us to shift it to the right 3 units. Okay, now here's the, I guess we'll call it an issue, right? Or now what we have to be concerned about with this problem, okay? And the idea is, okay, well, let's draw this out, right? We know that we're going to be shifted to the right 3 units, okay? So our graph should look a little something like this, okay? Not exactly perfect or drawn to scale, but we're going to be a U shape, okay? When you're looking at this and say, okay, it's a function, it passes the vertical line test. Okay. However, it does not pass the horizontal line test, right? There are points on the graph that have the same y value, okay? So across the whole domain here, it will not have an inverse, okay? But here's the key, right? This is the key. X less than or equal to 3, what does that mean? Okay. It means that we're only going to take parts of this function where the x values are less than or equal to 3. Okay, which means, okay, well, okay, here's 3, right? We're only going to take the part of the graph for the values of x that are less than or equal to 3. Essentially, we're only taking half or part of this function, right? Basically, in this case, half of the U shape. So that eliminates this other half, which means then that, okay, wait a minute, now this will pass the horizontal line test, right? There are going to be no repeating y values for this particular function. Okay, that's good, right? So now this will have an inverse because we have restricted the domain so that there are no repeating y values, okay? So now, okay, now if it does have a function, then we can go through the steps and actually find the inverse function, right? So we know that g of x is equal to x minus 3 squared, right? So we need to replace this with y. So y equals x minus 3 squared, okay? Every y becomes an x, and every x becomes a y. So x equals y minus 3 quantity squared. Now we want to be able to solve for y. Okay, so I'm going to take the square root of both sides. Okay. And here's the key, right? This is a plus or minus. Okay, this should be a plus or minus right here. And then, well, some people like the y being on the left, so let's do that. And then y equals plus or minus radical x plus 3. But also, right, you have to consider, well, it's not going to be both positive side and the negative of radical x, is one or the other. So how do we know? Okay. Well, let's take a look, right? For the function, right, for g of x, what is the domain of the function here, right? Okay, the domain is negative infinity up till 3, right? Those are all the x values that are going to be on this graph. The range, we know from the graph, is 0 to infinity, right? The y values. We start at this y value, which is 0, and we keep going up, so that's going to be the range. So because we have an inverse function, right, the domain and the range should be the opposite of this, right? So the domain of the inverse should be 0 to infinity, because that's the range of the function, and the range of the inverse should be the domain of the function, right? So how are we going to draw the sketch of this graph, okay? So we actually need the negative part here, okay? So we're going to take the negative radical x plus 3, which means then, right, and here's another thing we can do, okay? We know that this point is 3 comma 0, right? This point is 3 comma 0. So we know that, okay, the point 0 comma 3 should be a point on the inverse, right? Because we just switched these guys around, okay? Similarly, if we pick the point, I don't know, let's pick the point positive 1, right? If you pick the point positive 1, then the point 1, 4 should, this is not drawn exactly to scale, right? But the point 1, 4 should be on the function here. When you plug in the 1 in here, right, we get positive 4. So similarly, the point 4 comma 1 should also be a point on the inverse. Take a look at the graph, right? The graph is going to look a little something like this. We're going to look a little something like this here. Okay? So essentially, if you pick an ordered pair on the blue graph, which is a function, right, and then you switch the x and y values, then that point should be on the inverse, right?